Ciao En. Good day. This is Dr. Dean Dotwason of Canadian Biosystems, and we're here to present to you some of our products for aqua. And Juvi,
Hi, good day. My name is Juvie Castillo. I am the animal nutritionist for CBS Asia Pacific, and we are happy that you are here with us today.
okay. I miss Vietnam. I've been coming to Vietnam for 10 years already, and it's with this pandemic, I hope everybody is all keeping safe out there. But we really miss traveling there. So we hope maybe within the next year or next year or the early next year we could get back. Okay, so without further ado, we'll start the presentation on the aqua. Um, okay, give me a second here. Oops. Okay. Okay. So the name of our product is Superzyme uh, CS for complete system. It's a unique multi-carbohydrates technology, and it was developed in Canada. Uh, it's in Calgary. Our office is in Calgary, Alberta, and the Canadian Biosystems started in was born in 1984. It was started by a guy. His name is Mr. Owen Jones, and he started it in 1984, and then in 92 he started having a partnership with the University of Manitoba in Winnipeg, which focused on fermentation extracts. So most of our enzymes, as you know, are all from fermentation extracts. And then in 2006, we opened our first Calgary manufacturing plant. And in 2011, we acquired a company in Oshawa, Ontario. Uh, and then in 2012, this is when we started exporting outside North America. So that's when we started in Asia. I started in Asia in 2014, and then straight through, and then by now in 2020, we have been exporting to 15 countries. Okay, so our main goal is to have our products on the farm gate first. So we try to be cost effective on the farm. So it's we our almost all of our products are reasonably priced. Uh, we in especially for our enzymes, we try to release the trapped energy and its nutrients. This is another solution. And as of now, as we know that most of the countries have been trying to take out the antibiotic growth promoters. So we have this antibiotic replacement technology, and we also have the solution in reducing environmental impacts with the use of our products. So all of our products are non-GMO. And who do we work with? So we work with feed millers, nutrition consultants, large integrators, and we also work especially with distributors or distribution partners, as we call it, and networks. As we go along, we also have partnerships with different universities. Okay, so our main research is done at the University of Manitoba, but most of our researches are also peer-reviewed. So we have also partnerships, and some of our studies are also done in other universities in North America, such as the University of Guelph in Ontario, the University of Illinois in the U.S., University of Georgia. There's also the Dalhousie University, and also Chungnam University in Korea. And we also partner with other industries because some of the ingredients that we all use in our feed sometimes comes from this industry. So, for example, BVGS would come from Husky, which is a company in Canada that does the gas, and they've been taking the ethanol out of some crops. So we have the DDGS from there, and then we try to uh, partner with them, since we also try to use our products with their into those ingredients. So where are we now? As of for global distribution, in Canada, as I've said, we're basically in Calgary and in Oshawa, Ontario. But we've also went to the United States already. So we started some toll milling in Delphos, Ohio. And just recently, we put up CBS, or Canadian Biosystems America, which is in Volga, South Dakota. In Asia, we've we've warehoused our products in Hong Kong. Okay. So where is CBS technology used now? So it's more around North America, South America, and in Asia. There's around 10 countries now that we're selling to Asia, and we're proud that most of our customers have seen how the products work. We're not as big as the other companies, but I would say that our technology would be one of the newest in the world today. So aquafeed issues. So we know that fish meal is a protein source. Give me a second here. So I'll just have to take out my screen here so that you could see the whole slide. So fish meal is a protein source, the main and critical ingredient in aquafeed. Now, the dilemma we have in quality fish meal is the high cost, and therefore there is a need for cheaper and more digestible plant protein sources. As we know now, soybean meals going high, but there are other cheaper sources too that's coming into the pipeline. So, so why do we need the enzymes now? So the need for exogenous enzymes would be far greater now because of these expensive ingredients, and this would be able to break down the NSP contents of these plant sources to improve the use of these energy and amino acids. Now, for the digestive system, sorry, uh, this is a simple diagram or a simple drawing of a shrimp digestive tract. So basically, what we try to tell you here is that most of the lipid and carbohydrate metabolism takes place in the hepatopancreas. This is where usually the enzymes really work. And for the fish digestive system, uh, especially for freshwater fish, we don't we know that the pH in the fish digestive system is just right for enzymes to work. Okay, so it's more in the acidic part, acidic spectrum. Okay, Juvie, can you take
Okay.
over?
Thank you, Doc. So for my part, I would be discussing about the Enzyme Development Platform 5 of Canadian Biosystems. It's actually the platform how we develop the formulation for our enzymes. But before we go to the EDP5, let me first discuss how really enzymes work. So most of our ingredients, they have this what we call anti-nutritional factors. And one of the anti-nutritional factors are non-starch polysaccharides. So basically, this non-starch polysaccharides is what causing the caging effect for the release of the nutrients. So the caging effect, instead of the energy being consumed, it's somewhat caging the energy that is supposed to be used. So therefore, the animal cannot readily access this energy because of the caging effect of the non-starch polysaccharides. So with the use of the enzymes, we were able to remove the caging effect of this non-starch polysaccharides and therefore release the energy that is supposed to be used by the animals. So basically, that is how the enzymes work. So, Doc, the next slide, please. So for us to understand the significance of enzyme supplementation, um, basically enzymes are used to address the negative effects of these indigestible components in feedstuffs by making them more available for the animals. So the basis for the enzyme development platform is that we have to release the starch granules that are trapped inside the cell wall. However, the main problem with this is that this cell wall for every ingredient is different. The structure is different. You have to use a different strain for every cell wall and for every ingredient. So the enzyme development platform of Canadian Biosystem determines the type of enzyme that could really break down this cell wall. Next slide, Doc. So to explain what is Enzyme Development Platform 5, actually it's a proprietary platform underpinning CBS leading edge multi-carbohydrates technology. So this is actually the basis for all our enzyme formulation. This is a 5-step process applied to all our CBS enzyme products. And this process would ensure a highly efficacious product for a wide variety of application. The enzyme development platform 5 has 5 steps. The first step would be ingredient evaluation. And then we have to identify, the second step would be identifying the target substrate. The third step would be the in vitro evaluation. The fourth step would be the in vivo validation. And then we have the final product development. So I would go through these 5 steps as we go along the presentation. Next slide. So the step 1 is the ingredient evaluation. So this is the stage wherein we gather or we collect ingredients that is indigent to a particular region or for a particular country so that we may be able to bring them to the University of Manitoba for it to be analyzed. So ingredient evaluations are continuously conducted both on local and global levels. The goal for this is that we could fully understand the regional ingredient usages for all key sectors of the industry. So when Doc Dean the first arrived in Asia, the first thing that he has done is to collect all the ingredients that are indigent for a particular country and then bring them to University of Manitoba so that we could go to the step 2. Step 2 is identifying the target substrates. So after collecting all these ingredients and analyzing it at University of Manitoba, we can identify and quantify more than 90% of the dry matter constituents in any given feed ingredient. So the method that we used for this particular process incorporates validated, peer-reviewed methodologies so that we could quantify the indigestible components that are within the feed matrix. So for this particular method, we are given we prioritize to low digestible compounds like non-starch polysaccharides, as I've mentioned before, like oligosaccharides, also the phytic acid, some glycoproteins, and resistant starches. So in this step 2, we were able to see what are the substrates that the enzyme could work upon. For example, this is the chemical composition of a corn. When you what we can see here upon analysis of the upon profiling the non-starch polysaccharide content of corn, if you can see the green part of the pie, that is actually the non-starch polysaccharide content. We cannot do anything about the gray part. So the enzyme cannot do anything about it. The enzyme would work on the green part. And the figure below is actually the non-starch profile of corn. So the NSP of corn is 6.35%. So most of the farmers, they think that if they are using corn, they no need they would be not needing using enzyme anymore. But we can see in this slide that even corn has a non-starch polysaccharide content that the enzyme can work on. Next slide. So this is the chemical composition of a soybean meal. So compared to corn, soybean meal has a higher non-starch polysaccharide content. So corn has 6.3%, soybean meal has 14.7%. So this is the part where the enzyme would work on. Next slide. So for a typical corn soy diet, composing of 60% corn and 30% soybean meal, the non-starch polysaccharide content of that diet would be 15%. But for a fish feed, since soybean meal is being used at a higher content, maybe the non-starch polysaccharide would be higher than 15%. So the enzyme could really work on a lot on a higher level of substrate. So enzyme is really needed for fish feeds because of the higher level of non-starch polysaccharide contents. Next slide. So the step 3, so after gathering all the ingredients and then we have analyzed the substrate or the profile of the non-starch polysaccharide, we now go to in vitro evaluations. So using proprietary screening assays, again developed at the University of Manitoba, high throughput evaluations are conducted to determine which enzyme solution is best for each feedstuff. So this is where the concept of strain specificity technology comes in. So it is applied to select enzymes based on their ability to break down target substrates within a given feed matrix. So this is where we find out which enzyme could hydrolyze the NSP that was profiled from the given ingredients. Next slide. So for example, let us look at the NSP depolymerization of corn. So we have a control without the enzyme. We can see that the NSP content is 74.9. So when we analyze or when we look for enzymes that could work with the NSP of corn, we first test for the silanase. So from 74.9, the NSP content becomes 70.9. However, when we add a glucanase activity to the silanase, it further goes down to 64.1. And then if we add another enzyme, which is cellulase, so we are now using silanase, glucanase, and cellulase, the NSP content went down to 62.8. So that's a big leap from 74.9 to 62.8. So that is how we formulate the enzymes. We analyze which enzyme or which combination of enzyme that would work for a particular ingredient. So the same process is applied to the NSP depolymerization of soybean meal. So we were able to see the correct combination of enzymes and the correct strain to bring down the amount of NSP to 110 coming from 148. So the same happened to rice bran and wheat. So that is the step 3 for the enzyme development platform 5. So for the step 4, after that we've found out the correct enzyme combination to address the substrate, we now go to in vivo validation or animal trials. So the best candidate preparation resulting from in vitro evaluations are validated within in vivo studies. So we don't stop at in vitro test. After finding out the correct combination of enzyme, we don't stop there, but we also do animal trials. So each study is carried out using state-of-the-art equipment and validated experimental protocols. And these studies are conducted under the supervision of world-class researchers at leading universities and scientific institutions around the world. So in the next slide, you will see the several trials that we have done. These are the in vivo validations that we have done for our enzyme. It's for broilers, it's for layers, it's for swine. so that we will be able to validate the result of the in vitro analysis if it would translate to animal performance. So in the next slide, you will see one of our trials for Pangasius that we have done for Super CS and how it improves catfish performance. So in this study, a total of 17,502 fingerling hybrid catfish were placed into two high-intensity raceways measuring 24.4 meter by 4.5 meter by 1.2 meter. So one lane was fed a standard commercial ration, which you can see at the table 1, while the other raceway received an identical ration, but Super CS was added at 1 kilogram per metric ton inclusion rate applied as a liquid post-pelleting. So for the results and discussion, in the next slide. So compared to the control group, the fish that received diet supplemented with the enzyme Superzyme CS had lower gross mortality. So we can see that 5.9% versus 18%, that's a significant amount reduction in mortality, resulting in more fish being shipped at the end of the study period. So it's an additional income for the farmers. Furthermore, the fish-fed diet supplemented with Superzyme CS had greater body weights compared to the control and with lower FCR also compared to the control fish. So these results indicate that the supplementation with Superzyme CS has the ability to improve the performance and, more importantly, the profitability of catfish raised under intensive conditions such as raceways. So in conclusion, as a bottom line, Superzyme CS supplementation, sorry doc, previous slide, resulted in greater total weight shipped. Also overall mortality was reduced, increased body weight gain, and improved FCR. And there was also a significant economic savings can be realized by supplementing catfish diets with Superzyme CS. So finally, after in vivo trials, we now go to the final product development. So after validating it in the laboratory and after validating that it can work in animal performance, the final step would be the final product development. So we develop branded product solutions that are brought to market after validating end user requirements. So this is the step wherein we also undergo thermo and shelf stability and the regulatory compliance. So we also, in the EDP5, we also have continual development protocols ensure that each product solution remains technologically advanced. So that the technology that you see today may not be the technology that we offer in probably in 3 or 5 years, because we constantly innovate our technologies. Next slide. So in summary, the importance of EDP5 is that we at Canadian Biosystems are able to understand the profile of an ingredient. We are also able to determine which strain and specific enzyme activity that is to be used for that particular ingredient. We are also able to validate the laboratory tests in the live animal. So in conclusion, all of our enzymes doesn't have any guesswork. All are tailor-made to address the effect of non-starch polysaccharides in the feed ingredients. So for the application of EDP5 to the development of Superzyme CS, Dr. Dindo would be discussing the concept of strain specificity. Doc.
Okay. Thank you, Juvie. So as we go for the concept of strain specificity, okay, what does this mean? So strain, so as you know, our enzymes come from either bacterial or fungi, okay? But there are different strains of fungi, Okay, so as you know, there's different species of fungi, and because of this different strains, I will show you how we practice this EDP5 that Juvie just explained to you. This is the actual work, and this is why we had to call it the concept of strain specificity. Okay, so we'll give you an example. So uh, around 5 years ago, we went to a big feed mill in the Philippines, and you know how it is when the corn starts to come up. These big feed mills, especially for flour mills, who also have their own farms, they would try to source their own wheat. They would use their own wheat to to substitute for some of the corn. And in the Philippines, for example, one of the cheapest imports for wheat is coming from Australia. Okay, so Australian wheat is a lot cheaper when it's imported into the Philippines because of the good trade agreements. And in this example, uh, in the superzyme that we used to have back in 2015, ours, the silanase and the cellulase that we were using came from this strain. This is the fungi strain Trichoderma rhizae. We just call it strain one, as we because we started to develop different kinds of strains for this Trichoderma rhizae. So if you look at this, this is the number. This is for Canadian wheat. This is the number of NSP that is broken down. So the higher the number, the better, because there'll be more NSPs that can be broken down. Okay. Oops. I don't think it really went on. Give me a second. So anyway, when we applied the other strains to Australian wheat, we were able to find out that the other strains would be better used in hydrolyzing Australian wheat. I'm sorry we couldn't show you the animation here, but the what we're trying to show is that we've found that there are other strains that can be better used for Australian wheat. Okay. Okay. I think this is a better illustration of what we're trying to tell you. Okay. So for example, Trichoderma rhizae, which is strain one, which is a fungal strain, we get these enzymes from this strain, and we use it in 4 different kinds of wheat. So we have the Canadian wheat, Australian wheat, Argentinian wheat, and the Ukrainian or the Russian wheat. Okay, so you could see that the highest number is 36. So this strain can easily hydrolyze Canadian wheat at a higher percentage. But if you look at how it hydrolyzes Australian wheat, it was very low. This is the reason why we started looking at other strains. Because when I sent this Australian wheat back to Canada to our researchers in the University of Manitoba, they found that these strains that we've been using in Canada for Canadian wheat wasn't very effective on Australian wheat. Okay, so we started to look for other strains. So we used the fungal strain Aspergillus niger, and you could see that still we're not. It's very good in Ukrainian wheat. Okay, and for the Trichoderma rhizae strain 2, which is another strain apart from this, and then we have the strain 3. So here on strain 3, we found it the best to hydrolyze Australian wheat, okay, and Argentinian wheat. So what happens now is in the new product after 2015, we started adding all these strains into the product, okay? So the same thing happened with rice bran. When we started sending rice bran back to Canada, when we started looking at rice bran, on the control here, you could see that we could hydrolyze the content is 118, and we should be able to lower this number. Okay, if you compare this, like for example, if I show you hard pollard, the control or without the enzyme, the total NSP is at 325. But when we applied the enzyme, we went down. to 239. So this is a very successful hydrolysis. The same thing with cassava. Started with 69 and then it went down to 58. So this is very good. But look at rice bran, it even went up. So this means that this was not a very successful hydrolysis. And this is in October 2015. So we started to realize that not all our enzymes that we use in Canada are really working on Asian ingredients. So what happened in 2016, this was after how many months, we were able to find the right strain of the where we could get the enzyme from. And you could see here with rice bran at the control of 123, we were able to bring it down to 99.4. And as we found more and more strains, we were able to get even below 99.4. So this is what we mean by strain specificity. If we were not able, if we were to compare this to the first one, so this is the first strain that we've been using in Superzyme. It did not work for rice bran, and then we found the right strain. Now it's better. Okay, so this is the same thing when we got the cassava DDGS from Vietnam. This came from Vietnam, and you can see that when we applied, so this is the control, okay? This is the cassava meal from DDGS cassava meal from Vietnam without the enzyme. But as soon as we added enzymes with pectinase, we were able to hydrolyze 343 of the NSP down to 320. We added the pectinase plus the silanase, glucanase, and cellulase from 320 down to 319. But look at the big difference when we started looking for other strains and other other enzymes from different strains, from 343 down to 304. So this means that we now added that strain into the product so that if you use this cassava DDGS in Vietnam, it would work. So in summary, this is what is typically happening. So at the start, we were only having one strain. And now you could see silanase. Our silanase would come from 1, 2, 3, 4, 5 different strains. And these different strains would have different percentages of activity. Same goes with cellulase, glucanase, and all down the line. Okay? So this is why what we meant by the product we have now, Superzyme, is made of multiple enzymes coming from multiple strains. So in the Philippines, because of those so many ingredients, we were able to send them into our researchers. We were able to add more units of activity, not because of just adding silanase, but because of the different strains that we've added. And you could see that in 2015, this was the enzyme that we had. And in 2018, we had to re-register the whole product because you could see that the product here has been increased. The enzyme activities had been increased. Okay. One of the things that Canadian biostatisticians could also do is that we could also analyze different enzyme brands. So these are different enzyme brands, and you could see that the comparison between Superzyme and all these enzyme brands on the enzymes that are available in each product. So ND means non-detected. So for example, with this brand, you can see that they don't have invertase. This is another brand. You don't see amylase, protease, or invertase, and the rest is here. But you can see that but remember that all these enzyme activities are coming from different strains. Most of the other enzyme brands would always come from one strain only. Same with this slide, different competitors and with Superzyme. BDL means below detectable limit. Okay, so what are the key points on strain specificity? So feed substrates from different feed ingredients are variable and they're very resilient, not easy to break down. And sadly, not all enzymes will respond similarly between ingredient substrates. So that's so that the combination, the right combination of enzymes will be the key to open up these ingredient substrates. Not all enzymes will also respond similarly within the same ingredient type. So what do we mean? If it's Australian wheat, it might be different from Canadian wheat, would be different from Australian wheat. Now I think we have black sea wheat. So this is one of the most recent that we've started opening up, black sea wheat. A diverse or broad spectrum for enzyme activity is key to maximizing substrate hydrolysis. Okay, so actually, if we add to this, aside from having a broad spectrum of enzyme activities, we also have to have these enzyme activities coming from a broad spectrum of strains. Okay, Julie, do you want to come for this, or do you want me to finish this? So, multi-carbohydrates technologies that we have for Superzyme, multiple strains expressing multiple activities blended into one product, which is Superzyme. The strains we have are bacterial and fungal. This could be Trichoderma, Aspergillus, or Bacillus. And the expression products, which are the enzymes, are used in these final products. Strains are selected based on their ability to express enzymes. As you see in the last slides that we showed, it's not easy to find the right the enzymes from the right strains. Yes, it takes a lot of database and a lot of experience to find out the right strain from which these enzymes would come from. And multi-carbohydrate platform allows for regional flexibility. So this is why when we go to every country, we have a different formula for Superzyme. So in short, we would say our formula Superzyme for Vietnam would be different from the Superzyme in the Philippines, would be different from the Superzyme in Indonesia, and so forth. Now, we also have some supporting services for this. So for enzymes, we have Feed Check or Feed Check Express. So Feed Check Express is a quick test kit. So it's a qualitative Feed Check Express kit. We give it to you. Use the kit. Basically, you put your finished feed into this kit, and you would know if the enzymes or if the enzyme that you've used on your feed is still there after pelleting. MicroCheck is a mycotoxin test kit. It's not really a kit, but it's a service that we can provide. You submit to us your feed grain, and we would analyze the mycotoxin load in it. We also have a product for mycotoxin, which in Asia we call Toxifer. Okay, so that's all about bioplatforms, CBS bioplatforms. These are all the platforms of our products, and we would like to invite you to stay up to date. We are on Facebook, we are on Twitter, and you can also subscribe at canadianbio.com on the internet, and you can say hello to us there. We have someone who would chat with you there if ever you have questions, and that's it. So we would like to remind you that all our products are being innovated every once in a while, and I would say that maybe after 2 years you would see a different product again, a different Superzyme. So that's all our company is. We are all research and technology, and we are all about innovation. So thank you very much. Hello, Juby.
Yes. Thank you for your attention, and we hope that you were able to impart some useful information that you could use in your day-to-day operation. Good day.
Gamong. Thank you.